All right, guys, today we're going to continue compound inequalities. We're going to pick back up from yesterday where we left off. I just want to briefly review a little bit, go over a few things again before we pick it back up with examples. So for and inequalities, you're looking for the overlap of the graphs to determine the solution set. Okay, so since they're going to overlap, if we had an example, can y'all see that? Yeah. An example, and we had x was less than 8 and x greater than 2. Okay, we have two separate inequality statements, but when they're combined by the word and, you can write or combine these two separate inequality statements into one inequality statement. Okay, so when we write that one inequality statement, they like to keep the symbols as less than or greater to. Less than or greater than? Sorry. So we would change this one, okay? By change it, what I mean is we would flip it so that the symbol was going the other direction, but we can't just change the symbol. We would have to flip everything. So we would flip our 2 to the left side, flip our symbol, and then flip our x to the right side, okay? This didn't change anything. The greater than mouth is still facing the x. The greater mouth is still facing the x, right? So either way, x has to be greater than 2. X has to be greater than 2, right? 2 is less than x, 2 is less than x. They mean the same thing. I just wrote it in reverse order, right? So then what we do is we're basically keeping this x where this x is, we're moving it down, and we're just going to shift the less than 8 in front. Right? So we have two separate inequalities still. We have x is less than 8, which is what we have here, right? And then x is greater than 2, which is what we have here, x greater than 2, right? So they can be combined and written as one inequality statement. All right, so if we were to graph this, we would have two smaller numbers on the left, right? Larger numbers on the right. If I were to graph this first one, x is less than 8. Then we're shading everything to the left of 8, right? And then x is greater than 2. So we'd be shading everything to the right of 2, okay? So since these are combined by the word and, then we're looking for just the overlap, okay? So the place where these two overlap is right here in the middle in between 2 and 8. So that's why we would get the graph like this to be our answer, okay? And then for or inequalities, any area shaded on the graph is part of our solution set. Okay, so it's not like above where it's just the overlap, it's any area shaded. Okay, so for example, if I had the two inequalities, x is greater than 5 or x is less than or equal to -1. Okay, these, when they're or inequalities, they can't be combined and written as one statement, okay? Because it's not like this graph where they're just going to be shaded in the middle of the two. Like this inequality, the x is in the middle of the 2 and the 8, right? This is different. You can see that on the graphs when we graph them. -1 is smaller, it's somewhere over here on the left, and then 5 is somewhere over here on the right. Okay, with -1, it has the or equal to under the inequality, so that circle is getting shaded in. 5 doesn't, so we're leaving that shading open. We want any x value that's greater than 5, so all the numbers greater or larger than 5 are over here to the right, and any x less than or smaller than -1, so all these smaller numbers are to the left. That is the difference in the two graphs. Okay. So and inequalities can be written in two separate ways, kind of like we were talking about up here. They can be written as two separate inequality statements, or they can be combined into one single statement. So you could have two separate inequalities here, combined by the word and, or if they're written in one single statement like this with your two separate inequalities, this is also an and inequality. For this first one, we're trying to get x by itself always. Our inequality is what separates the left side from the right side. If you like drawing the line, keep track, you can. So to get this x by itself, we first need to cancel out this term adding or subtracted to it that doesn't have an x. So to cancel out a minus 5, we're going to do the opposite and we're going to add 5. Okay? Because negative 5 plus 5 is 0. So then we're just left with a 2x is greater than or equal to 8. Okay, x isn't quite by itself because it's still being multiplied by this 2. The opposite of multiplication would be to divide. So that's what we're going to do. 2 divided by 2 is 1. So we have 1x is greater than or equal to 4. That is our first inequality. So for our second inequality right here, we have x plus 4 is less than or equal to 9. Okay, so to get x by itself, we're going to subtract 4 from both sides because the opposite of adding 4 would be to subtract 4. 4 minus 4 is 0. So we get x is less than or equal to 5. Okay, those are our two separate inequalities, right? Let's look at them on the graph. So we have 4 and 5. Both of these can be shaded in circles because they're both have the or equal to part. Okay. So for this one, it says any x greater than or equal to 4. So we'd be shading here and then anywhere to the right, greater than 4. For this one, we're taking 5 and we're shading anywhere less than 5. Okay. For and, remember we want the overlap. Well, the only place they overlap is in the middle. So just right here in the middle is where we're shading for our and. Okay. So since this is an and, like we talked about earlier, we can also write this together to represent this statement, right? We can combine these two separate inequalities into one single inequality statement. With our x in the middle, so we know x needs to be less than or equal to 5 like we have here. And then x also needs to be greater than or equal to 4. Okay? If I'm reading this, x is greater than or equal to 4 and x is less than or equal to 5. We basically took this inequality and we flipped it. So we put 4 on the left, flipped our inequality statement so that the smaller part, close part, is still facing our 4. And our x moved to the right, so the open part of the mouth is facing the x. And we just took it down here. Okay. And then the other way this can be written in interval notation would be like this. Both have the brackets around them because they both have closed circles. All right. So example number 2, where we take an and inequality statement, but it's written as one combined inequality. So for this, whatever you do to get your variable in the middle by itself, you must do to both of the other sides, right? So I'm going to draw 2 lines here, because I have 2 inequalities. So really I have a left side, a middle, and a right side, okay? So we're looking in the middle to get n by itself, we need to cancel out that plus 5, right? So to cancel out a plus 5, we would do minus 5. Since I have 2 other sides, I need to do minus 5 on both of those sides as well. Okay, so then I have a negative 4 minus 5, which is going to give me a negative 9. 5 minus 5 is 0, so we're just left with our 3n in the middle. And then 11 minus 5 is 6. Okay, so in the middle, we're closer to getting our variable by itself, but not quite. So 3 times n, the opposite would be to divide by 3. And when we divide the middle by 3, we have to do it on both of the other sides. So negative 9 divided by 3 would give us a negative 3. 3 divided by 3 is a 1, so we're left with 1n. And 6 divided by 3 is 2. So that would be our inequality statement, also known as set notation, and then we could also do it in interval notation, which would be negative 3, comma 2 with a parentheses, right? Okay, and then our graph, our number line, negative 3 gets the closed circle, 2 gets an open circle, and they shade in the middle. Good? All right. Last but not least, we want to go over just an example for OR inequalities as well. Okay, let me zoom this out a little bit, focus it again. All right. There we go. So we have 2x plus 4 divided by 3 is less than or equal to 6, or 3x minus 2 is greater than 22. Okay, so we have 2 separate inequalities combined by the word OR. Okay, so we're just going to solve each of these 2 inequalities. So for this first one, okay, 2x plus 4 divided by 3, we're trying to get x by itself. I can't start canceling out this plus 4 yet until I've gotten rid of the divided by 3. So first thing I need to do is cancel out this divided by 3. We know the opposite of division is multiplication. Okay, so I'm going to multiply both sides by 3. 3 divided by 3 is 1, so those 2 cancel out. So I'm left with a 2x plus 4 less than or equal to 6 times 3 is 18. Now I can start solving it like I did the others. So I can cancel out this plus 4 by doing a minus 4. And I have 2x is less than or equal to 14. Cancel out a 2 by dividing by 2. Or cancel out the 2 being multiplied by our x by dividing by 2. So we get 1x is less than or equal to 7. Or, and now is our other inequality. We have 3x minus 2 is greater than 22. So we would add 2 to both sides to cancel out this minus 2. And we get 3x is greater than 24. To cancel out the 3 that's being multiplied, we're going to divide both sides by 3. And then we get x is greater than 8. So those are our 2 inequalities. X is less than or equal to 7, or x is going to be greater than 8. And if we put this on a graph, 7 and 8, 7 gets a shaded in circle because of the or equal to part. X stays as an open circle. We want any of the x values, so any numbers on our number line, any x values less than or equal to 7. So we're shading left for less than. And any x values greater than 8. So we're shading to the right.